some of the issues that Molly covered about the experience involved in services, Berkeley has actually undertaken, as has a couple of other CITRIS campuses, notably UC Santa Cruz. And we're starting to explore services with a capital S. And this is research in a discipline that provides fundamental insight into how services should be designed, conceived, developed, deployed, et cetera. It's a discipline called Services Science Management Engineering. Now, for those who've worked a long time in healthcare, there's a lot of envy for other domains like banking and grocery stores, et cetera, that have very tight controls over their processes and very granular data about what's happening in the field. Our next speaker has actually worked in this area. Robert Morris is Vice President of Research, Services Research at IBM. And as you well know, IBM has done work in many, many fields, and they've been a long collaborator with Berkeley from everything from energy to now services. I'll mention that this exploration of services represents a new way of thinking for healthcare, and certainly very large portions of economic activity. And what Robert will cover for us is how IBM looks at this field of services. So without much ado, let me introduce Dr. Robert Morris. From 2004 and 2006, he was Vice President of Asset Innovation at IBM. And in this position, his mission was to drive innovation in IBM services through four main activities. The creation and commercialization of intellectual assets, and Robert will define what that is, that can be used to improve service effectiveness. The creation and management of services, methods, and tools, knowledge management and tools, and talent, all of which are core to innovating in services. So, without any ado, Dr. Robert Morris.
Thank you. So, thanks so much, Ravi, for inviting me, and I'd just like to thank Molly for laying out a pattern in healthcare which is so consistent with everything that we've discovered, the importance of the business model, the importance of the process, and the importance of the delivery, the way we do the delivery of services. And so I will back up and give you a broad spectrum view of why services is so important and some of the fundamental things that we have to reconsider as we execute on services, we deliver services, and we do the underlying research in services, which CITRIS, thanks to Ravi and his team, have now engaged in a very big way. And then I will continue giving some explicit examples from healthcare. But I'd like to start with the big picture of services. And let me do that by asking, first of all, why all this fuss about services? And what it really comes down to is the fundamental change that has come upon our economies worldwide. These charts here, and some of you may have seen these before, these are workforce distribution charts, what people are engaged in, what they spend their time doing these days. And you will see the blue area is agriculture, the yellow is manufacturing, and the gray is services. The advanced countries have become, in terms of employment, predominantly services economies. The bottom axis ranges from 1800 to the present. And as you can see, 200 years ago, we all spent most of our time getting food. And in the intervening period, we've now reached a point where in advanced countries, just a very small fraction of our time is spent getting food. A smaller amount than before. The manufacturing and the product revolution has come and actually declined, and services has become the dominant part of the economy. And even in developing countries such as China and India, very rapid growth in services. So I just ask you to stop and pause for a minute and ask, why did this happen? Why is it that these changes have occurred? And to consider that, I'd like to actually take you back to prehistory, take you back about 6,000 or 7,000 years, and ask you to consider one of the great technological advances of all time, which is the invention of agriculture. We used to gather food and hunt food, and then about 6,000 to 8,000 years ago, agriculture was invented. And suddenly, there was an incredible change in mankind. And in fact, most things that we consider modern culture and modern advancement began at the time of agriculture. Even the religions, the great religions, all sprang up just after the birth of agriculture. And why did this happen? And it's very interesting to think about why agriculture was so important. What happened was, and this is consistent with what we just saw, we moved from a model where we were all spending all our time hunting and gathering food, a very inefficient process, which took all our time, and even then we were hungry half the time, to a point where there was plenty of food. In other words, there was a massive productivity increase in this mission of fulfilling our fundamental human needs, right? And that productivity meant that we then had time left over. We didn't have to move around so much, and there was time to do other things. In fact, that productivity advancement led us to a period of specialization, where we could now have people that specialized, some still specialized in food, but others specialized in arts or in the making of tools that other people could use, or in religions, or in warfare, okay, or in various roles. And some would say that that specialization, because of the change in what we were doing, actually also increased our productivity. Okay? But what is the situation that we got into then? Well, this specialization inherently caused our lives to become far more complex. By all means, it's pretty obvious that if you introduce all those different things, introduce arts and sciences and literatures and religions, then your life becomes more complex. And in fact, just think about our lives today. Today, we have to pay people at UC Berkeley and preceding education 16 or 18 or 20 years. We have to pay specialists to educate our children. We have to go to 2 or 3 levels of specialty, sometimes in healthcare, in order to maintain our health. And we've all learnt or wished during the last few days that it's probably good to get advice about how to manage our personal finances, right? We go to specialists to manage our personal finances. We can't do those things anymore, right? And so we have to go to get services. And so, as a result of that, there has been an incredible need now for trade and services. Okay? So this is one explanation of how we've gotten there. And interestingly, as services has come across us, I only noticed this personally about 5 years ago. I've spent most of my career as a computer scientist doing product research, doing theoretical work and work that supports the delivery of products. And I suddenly realized IBM had suddenly become 50% a services company. And I started thinking about what do we need to do and what different technologies need to be created and how do we need to apply technologies different to address this situation of services. Now, technologies have come and gone and they've changed. And I don't know how many people here are familiar with the work of Carlota Perez, but it's very interesting to look at the path of technology. She's mapped out in a very interesting way 5 ages of economic and social transformation. And in fact, it's very arguable that the Industrial Revolution was one, the age of steam and railways was another, etc., through to the one which we're presently most engaged in, the age of information and telecommunications. And interestingly, if you look at the actual data and the facts, all of these revolutions last about 50 years. They're all punctuated in the middle with a bust. Okay? And in the first part, they go into installation, and then after the bust, they go into this period of deployment. Now, if you believe this theory, we certainly just had a bust a couple of years ago in information and telecommunications. It looks as though we may be coming into a period of institutional adjustment. And so what is this going to mean? Certainly in the field that I referred to before, the field of information technology that IBM is engaged in, for us it has meant the change from a product company to a services company because of the complexity of information technology. People now come to us and say, take it off my hands, implement my systems. They're too complicated, they're too risky, they're too hard to manage. Please do it for me. And that's in fact what has created the information technology services business. But what is happening on a global scale as a result of this? Very interesting global effects are being faced. And in fact, one, of course, is the emergence of global talent. And many of you have read The World is Flat. The doubling of the labor pool, shown by some of the red dots on my map there, where incredible amount of talent, which was there before, is now becoming available because of the telecommunications revolution. And they're very well attuned to delivering services. This is causing problems. As you know, there's a lot of arguments going on at the moment about whether that means that in the red regions or the growth regions there will be a growth of economies, and in the some other regions there'll be a loss of jobs and there'll be a bust of some kind in those economies. And we have to ask the question, is this inevitable? Is this something that's going to happen? Because, as international economists will tell you, it is possible for this change to occur in a way that is a win-lose model. It's also possible for it to occur in a way that is a win-win model. And some of the effects that are occurring as we observe them, which are actually making the outcome much more likely to be a win-win model, if they're adopted, are, for example, the exchange of technologies and letting the best technology win through open standards and componentization, which is probably the biggest single revolution that's going on now in the implementation of software technology for information technology, a whole variety of new collaborative tools and organizational models, and above all, the empowerment of individuals, the empowerment of individuals to create and innovate regardless of where they happen to be located. So our belief is that if we have open standards, if we have clear layers, and the layers of technology are allowed to interact according to open standards, we actually have the potential to create a growth model on a global basis. But of course, one thing that this asks naturally is, those of us who work in information technology, probably we have plenty to do for 25, 30 years during this period of deployment. But if there is another revolution, technological revolution coming, what is it? And if you ask people, and I regularly do this with summer students and people that come into our labs or our clients, I ask them what they think it is. And there are various theories, there are various beliefs as to what it might be, but I think you can guess that the predominant belief and the vote that you most often get is that we're headed for a sixth revolution, and that revolution is biotechnology and health. Okay? And I think there's a reasonable amount of evidence, and I'm going to show you some examples later about the amazing things that are happening, in addition to the things that you just saw from Molly. So, before leaving the topic of the general field of services and what's happening in services, I'd like to just give you one caution. And I'd like to ask, how many people here have heard of Baumol's disease? A couple have heard of that. So I'd ask you to think about, go back to those three sectors of the economy, agriculture, manufacturing, and services, and think about what will happen if we need every one of them. We certainly still need food, we need some products, right? And we need services, unless we decide to go back to a much simpler lifestyle, which I don't think is going to happen, right? If those are all compulsory, now let me ask you to consider what would happen if the growth, the productivity growth in one of those sectors became slow. Well, the productivity growth in agriculture has been fantastic. You saw the disappearance of that as an occupation. The productivity growth actually in products has also been fantastic. I'll give you just one example. Moore's Law, improvement 40% per year in information technology. Similar efficiencies are found in other fields of production and manufacturing. The improvement in quality in automobiles has been fantastic. Okay? But services has not participated in those increases in productivity, nor for that matter, quality. Typically, we see 2 or 3 or 4% improvements in productivity in many service industries. They're labor intensive. Technology is around, but it's not being used that much, and we just heard examples of that. And so now what happens in an economy where productivity, the blue line of goods, continues to go up, but services remains essentially flat? Well, if you still need all three, and if you have a mobile labor workforce that can move between them, then something is going to happen. You either have demand elasticity, and we all stop using those services. We all stop using Berkeley to educate our students. We go back to 3 years of education. We stop using medical services, right? And then we just have services death. Services too expensive, not productive, won't use them anymore. Unlikely to happen. Or something else happens. Services, as we saw, taking a larger and larger amount of the economy, begins to completely dominate the economy. And because its productivity is growing slowly, the entire GDP grows slowly. Okay? And we have an economic problem on our hands. This is known as services infection. Okay? And in fact, it is now being recognized as a significant worldwide economic problem. It was first pointed out by Baumol in the 1960s, has been measured very closely by economists. A couple of times we've been told services productivity is okay, it's getting better. IT is beginning to be deployed particularly through 3 segments of the services economy. 3 segments have had particularly low productivity growth: health, education, and government. Several other sectors have had actually reasonably good productivity growth. Financial services, quite good productivity. Information technology, interestingly, somewhere in the middle, quite good. What happens? The whole thing grows, and we get into this low growth period. Information technology has been suggested as a few times as beginning to make a difference. In fact, there have been articles, Baumol's disease is cured. IT has saved the day. But just recently, if you read the Wall Street Journal, about 6 months ago, there was an article saying, no, very clear signs that productivity growth in key segments of the services economy is really slow, and Baumol's disease is back. Thought to be in remission is now back. So this is one of our challenges. It's the challenge that I signed up for a couple of years ago to go into our services business and do what we called assets innovation, use technology to fundamentally change the nature of services. And we've had reasonably good success of that, and we're really starting to get some significant productivity and quality growth by doing that. So this is something to watch out for. And I would say the problem is particularly acute in labor-intensive industries like, for example, health, where patient contact is needed. However, things can be done, as we saw in the last talk. In education, where people expect face time. Okay? So what I'd like to do now is say, what are we going to do about these problems? How can we make significant advances? And I'm going to use illustrations from information technology, which I know more about, and from health, which I know less about, but we have a lot of work going on in IBM and in the field, and I'll try to describe some of that. So the first thing we have to do, again consistent with the previous talk, is focus on the process. And since it's kind of getting late in the afternoon, I thought I would wake everybody up and we will play a game. Okay? And the game we're going to play is the game of 15. And your goal as a player is to, with any 3 chips, achieve a total score of 15. Don't go over, don't go under, and we're going to take turns. Okay? And we're going to watch red and yellow, and you can take sides. So red is going to play, and yellow is going to play. Red has, yellow's picked a 2, red's picked a 4, red's turn again, picked an 8, yellow picked a 3, red just picked a 5. And now the question is, what is yellow's next move? Anyone like to suggest what it is? What does yellow have to do?
6.
Someone said 6. Why? Red's got 4 and 5. That's 9. Okay, if you don't get 6, okay, with yellow and block that, he's going to get 15 on the next. First thing you've got to do is block your opponent, right? The response wasn't too far. I'm sure you all got it. It wasn't too fast. So I'd like you to think about it in a slightly different way. I rearranged the numbers into a 3 by 3 grid, making sure that the horizontal and the vertical and the diagonals all add up to 15. Okay? I think you all know this game now, right? Red has 4 and 5, and it's pretty obvious what yellow has to do, pick 6. So the point of this little game is not just to wake you up, but is also to ask you to remember that the way you rearrange problems, the way you structure problems, and the way you lay things out, and the way you visualize problems is a very fundamental technique in solving problems. And so I'd like to show you a typical kind of problem that I have to deal with on a day-to-day basis. This is the IT system of one of our clients, okay, when it was given to us. Okay, as it is the blue represents mainframe systems, applications that are running on mainframe systems. The green, I think, represents Microsoft systems running applications. And the yellow represents Unix systems. And as many of you know, all these systems now have a share and a place in running a large IT configuration. And there's obviously a lot of information flowing between them, right? So the challenge to you is reorganize this. Make this efficient, better, lower cost. Take this problem off my hands, which is what a lot of our clients say to us when they engage us to simplify or remove complexity from their overly complex life, right? So in light of the last experience that we had with the little game, this is how we reorganize things into a nice table. And this is a technique called the component business model, which we use to take all those systems which are kind of randomly arranged on the previous page and organize them into the roles in the columns that take place to run an institution, whether that be an educational institution or a hospital, okay? And then the functions, the grouping of the functions horizontally, direct, control, execute. There's a difference between directing something, actually controlling it, and running it at runtime, as we like to say sometimes. Once you do that, you can begin to see patterns and you can begin to make decisions. So, one of the main uses of this table, this is arranged in this way, is to have a strategic discussion. You have so many systems on there. Which ones are you going to excel in? And how does your strategy as a company map onto this model? Okay? We all know, those of us who have studied business strategy, know that there are only a few strategies. You can decide to have a product excellence or product differentiation. You can decide to have operational excellence, right? Or you can decide to have a customer intimacy or focus, right? What is the strategy of this company? This happens to be an automotive company. What's its strategy? Well, you can tell by looking at what they've decided to focus on in their IT systems in order to, you might even be able to tell what car this is. Okay? What have they decided to focus on in order to execute their strategy, one of the 3 exemplary strategies which I just outlined? They've said, I'm going to spend money and really tune up my IT components in the blues. I'm just going to be competitive in the yellows, and I'm just going to be an also-ran, or just basic capability, just get it done in the yellows. If you look at this car company, you can see they're very, very focused on things like their post-vehicle sales strategy, their customer relationships, sales planning, portfolio. Okay? They're very focused on the experience and what people think about their car and what their relationship, even post-sale, is. They're less focused on things like quality, although quality is important to them, but it's not the most important thing. Okay? And they're not that focused at all on cost. Cost of product. They're making an expensive, nice, high-image car. Okay? So this is a way to organize the problems of whether it be a hospital or an auto manufacturer or a telephone company, and arrange that into a model. This kind of thing is very powerful in terms of figuring out how the first step in optimizing process. Okay? So what do you do then? Well, once you've figured out what you want to focus on, then you need to take into account some other characteristics, take that component business model, take a process classification and think about how well you are currently performing and how well you'd like to perform in each of these areas. Think about your business processes, and then never forget where you are today. Think about the IT applications that you have running, and think about the people organizations that you have running the system. And it's amazing how often products, whether it be the products of a research organization or a university or any other organization, look like the organizations that create them. So don't forget about the organizations. And then figure out, based on your current performance, what you aspire to and how you're performing in terms of your key performance indicators, a heat map which says, let's focus on the red. Okay? And when you've decided that, before you make any investments, think about what the business case is for making any one of those investments. Okay, so you've now decided what you're going to do. Now we have to think about how to do it. Okay? Start with your strategy models. The traditional way is to use very informal operational models. Lots of flip charts, lots of whiteboards. Draw those systems and try to simplify them or lean them out, if you like, using the modern terminology of lean and lean sigma, and come up with some very structured, simplified, if possible, and IT models that are going to support your performance model. Okay? These semi-formal models are very hard to do well, because they require you to balance all that panoply of things, performance, process, cost, that I just showed you on the previous chart. And what is emerging is a completely new set of technologies within software called model-driven transformation. And what model-driven transformation requires you to do is to actually build an as-is model of your system, verify that it accurately portrays what your organizational and your information flows are, and model not just what the paths that take place, but how things change as they go through those paths. And then, having done that, go into a formal modeling process of transformation, which allows you to construct pieces of implementation, pieces of code, hopefully reusable pieces of web services software, which you can just call on the web instead of invoking a piece of code and compiling it and making sure that it works on your system, and bring together and compose a bunch of web services which end up meeting your requirements. The little story that I've taken you through is very different than the old IT. It's something that a specialist in the implementation of complex systems can do if they have all those capabilities and tooling available to them. And those of you who in the past have either tried to create information technology or have been on the butt end of that, namely waiting for the IT department to put some new technology together to give you a fundamental report or operational model that you need, will see the difference in this model. It's achieved a higher standard of specialization. You could say complexity, but if this works, this actually will result in simplification. And I can tell you it does work. It's actually the method that's now used in the most advanced implementation of IT systems. So that's process. And process is something that, in the end, is always the first order twist that you have to make. Okay? Having thought about process, I just want to say a little bit about quality. You know, quality, interestingly, I'm sure quality has there's no... We lost sound? How about this one? Is this one back? This one's not back. Okay, I'll use this one. So it's moved us from an era where we didn't know when we got in a car whether we'd get to the other end, to a period now where many cars are quite or very reliable. Okay? The same is not true in services. In fact, we would have to say that we have a quality crisis in services today. So let me tell you a little bit about that. And really, we need to start with, you can start with any number of press stories, and I've just shown a couple there, of people being very mad about the results that they're achieving from service, through to some real data. And what I've shown here is the sigma level for various services. And as those of you who know the normal distribution know that the sigma level is directly related to the number of defects in service. Very interesting results. Manufacturing of electronics boards is now about 6 sigma. Okay? IRS tax advice. You should know this. If you rely on the IRS for tax advice, you should know that when you call them, around 40% of the time, they will give you the wrong answer. Okay? Okay? So that's fair. That's not quite 1 sigma. They haven't quite made 1 sigma yet. Right? A couple of points from health, and these come from the literature, and I apologize if I'm offending anyone here in the health industry by stating these, but radiology is commonly quoted to have an error rate in terms of under-reading or over-reading of about 20%. So radiology is about somewhere between 2 and 3 sigma. Inpatient medication, meaning the giving of medication in a hospital, when is it either incorrectly given or when is it given more than 2 hours early or 2 hours late? Okay, this has a defect rate of about, as you can see from here, of about 10%. Okay, and which gets you to about 4 sigma. Airline baggage handling is about comparable with inpatient medication. Right? That's a kind of scary thought, right? And I have to confess, from our IT industry, the best of breed numbers in information technology, change management, is, if you're lucky, it's about between 3 and 4 sigma. And the implementation, the development of new features for systems and the maintenance of features is more like 2 sigma in the IT industry. Okay? And it's better than it used to be. Right? So as you can see, there's an incredible opportunity for somebody to come along and be a Toyota in many of these services areas. This is an unsolved problem. It's an incredible opportunity for doing research, and what's interesting about it is there are certain things that we can directly relate and translate from experiences in manufacturing and production, but there are also certain things that are fundamentally different. So how is that? Well, if you think about, in the bottom left box, what are some of the key concepts that came up in product manufacturing? Ideas like just-in-time, that manufacturing people are preoccupied with inventory. They know that, actually, the opposite of what naive queuing models would have taught us, that we have to drive inventory down. Okay? Visibility, being able to measure, getting people together to solve quality problems in a cultural process. And metrics. These are some of the fundamental principles. In fact, on the first one, I would say that manufacturing people are preoccupied with inventory. They're always talking about inventory and how to increase inventory turns and bring inventories down, work in process down, for all kinds of economic industries. So what's the analogy of that in services? Hey, wait a minute. I don't think we can't build services and put them on the shelf, right? Fundamental differences. And so we have to think about analogs of inventory. While we might not have inventory of services that we've produced that we're waiting to sell, we do have inventories of patients who are waiting to be helped. Okay, we have inventories of medical delivery workers, professionals who are waiting and may not be well matched against what they're what their job requirement is, right? And so we may have requests. We may have, in a consumer service operation, we may have a set of requests that are in a queue or in a phone queue waiting to be served. Those are certainly to be minimized, but very different things and quite different techniques. Other fundamental differences with services quality, and this has been mentioned earlier today, whereas in product, when you make the product, you put all the quality you can into it and you ship it, okay? And the whole control that you have over the quality of product ends with the sale. In services, when you sell a service, the experience begins with the sale. Okay? And from then on, throughout this period of so-called co-production, which you participate with the client, things are done together. And as a result, the experience and the relationship that goes on throughout that process is very fundamental and has been grossly understudied and is a huge opportunity to change the nature of services quality. Third thing, once you've got the fundamental processes right, and once you've got processes that make sense from a quality perspective, then in this time of scarce resources, optimize every possible resource. And let me give you a couple of examples of how we do that. So, for example, in information technology, what is the biggest cost? It's not the machines, it's not the hardware, it's not the software, it's the people who manage these complex objects. And this is the data. Look at the operational costs versus the capital costs. Right? It's all about people costs. So you have to manage the people and you have to manage the processes. Do you manage the inventory of people first, or do you manage the processes first? You start with the process. So the first thing you do is go and construct Paretos to find out where that time is spent. And interestingly, in information technology, this is where it's spent. 23% of effort is spent on migrating systems, 21% on deployment, 14% on monitoring, 14% on upgrades. So how do you address this? You can address it through process improvements of the type that I described to you earlier, or you can fundamentally make changes. And one instance of a change that you can make is the deployment of concepts like virtualization. Virtualization meaning putting together and lumping together and getting a virtual view of all your hard physical resources and treating them as a service. Right? And virtualization technologies are needed to do this. Now, for those of you who are in healthcare, I won't bore you with too many more IT details, but here's one that you will have to agree is fundamental. The deployment of labor. It's not just true in IT, it's not just true in healthcare, it's true in pretty much every institution in the world that the predominant cost is the cost of labor. Think of an industry where the predominant cost is not labor. I can't think of one. Maybe there's some gold refining industry where raw materials is a dominant cost or something. And what do you have to do? You have to actually use models and use techniques. And in fact, those of you who are familiar with traditional service systems, Jim Sporer likes to remind me that the term service systems has just begun to be used recently. But if you actually do a web search on service systems, you'll find there was a book in 1947 on service systems by Riordan on service systems. And it was about the big service systems of the time, which were telecommunications network. These are the equations of telecommunications, of trying to figure out what the blocking probabilities are of collections of trunks. It's exactly the same mathematics which now gets used and applied to availability of people, and how those people are deployed in different wards or in different services in a healthcare facility so that you achieve several of the effects which are shown by the various blue bars on the left. Those effects are what's the cost of deploying those people and what's the service. Very analogous to how many trunks I put in a telephone network and how often can't you get a dial tone. Okay, or do you get a busy because the service wasn't provided. The same mathematics, it turns out, is usable. However, there are changes. There are changes that are needed. So there's a huge resurgence of work and very good research work around the deployment of operations research models to deal with the optimal deployment of labor or of people resources. So this is one aspect of optimization, and one can easily see 5 and 10, 20% improvements that are possible when you get the right kinds of deployment of labor. There's one more cost. Actually, I said labor dominated the cost of hardware and software in information technology, but recently another cost has sneaked in. It's energy. Energy is now the second biggest cost in the majority of IT. And if you look at the specialized IT, which many of us use, for example, web search, those large data centers which run our web search for us, their largest cost is energy. It's not labor. Okay? So what can be done about energy costs? Of course, the price of energy has gone up. Well, remarkable new things are being done. Okay? And I've just shown here an example. I've shown the data of how energy is now actually beginning to this data actually shows it slightly less than server spending. So it's comparable at the moment. Maybe it's not second. New techniques or old techniques revisited are coming back into vogue. So the traditional way to cool a data center is to have lots of cold air in there. But have you ever wondered why the air in a data center is at about 13 or 14 degrees C when the warranty says you have to be at 20 degrees C? It's because the hottest spot is at 20 degrees C. And so if you can create technology to smooth out the patterns, which is a service that people now provide, or you can provide more efficient ways than air conditioning, then you can make huge difference. There is a way. Okay? It turns out air conditioning cooling is very inefficient because air is a compressible fluid, and by pumping air through machine rooms, it takes about as much energy to do the air conditioning to get the heat out as it does to spend to run the machines that are generating the heat. So half the heat is spent on getting it out of the room. The new technique, which is actually an old technique, is to use water cooling and to use warm water to run water through the systems at about 50 or 60 degrees C. It heats up to 70 or 80 degrees C. You just run it through a cooling tower on the outside with no chiller, take out the chiller, and run it back into the room at 50 or 60 degrees C, which is still very hot, but is good enough to cool a 100-degree chip. Okay? This is a breakthrough. This reuse of this technology is a breakthrough, and in fact saves about half. You've still got to pay for the pump, so it's not quite a 50% saving, it's about a 40% saving. This is a big breakthrough. And if you can reuse that heat on the outside in the chillers, okay, if you can actually use that for district heating, which there are about 5,000 communities around the world, including New York City, where there's a significant amount of district heating. In other words, water is created in collective centers and pumped through the ground, then we have a concept where you can recapture all that heat, and in fact you can almost get to a zero-emission data center. In other words, you've displaced the heating energy and you've used the IT energy to do that, and therefore there's no net added cost to run your IT. Okay? It's a wonderful concept and one that's starting to get a lot of attention. Finally, risk. The fourth step is to manage risk. And I'm not going to take you through the whole process there. I would just say that the whole process of management of risk has changed and received incredible amount of new attention. And in any service industry, it's become absolutely essential today to manage risk. The issue that has changed in risk, the fundamental issue, several things have changed. First of all, there are more risks than there ever were before. Okay? In many industries, the risk of non-compliance has become a major issue. The risk of natural disaster has also increased, as recent news stories will show you. And in financial services, for example, we've recently learned a lot about risk and the fact that our risk models were not working well for us in financial services, as an example. So what has changed that's really fundamental and might become very, very important to us? The first thing is the need to deal with complex systems and many risks all at once, and to do the correct allocation of resources to mitigate those risks. That's one. And a couple more are the need to deal now with rare events that are recurrent, such as warranty issues, fraud, IT failures, etc. They will happen. It's just a question of when and being able to deal with them. A second very important area is to deal with unprecedented extreme events, things that have never happened before, like pandemics. Why is a pandemic different today than it ever was before? The Spanish flu was bad. Why will it be worse if that happens again? One thing, air travel, right? So unprecedented behaviors of the systems, and perhaps even unprecedented behaviors in the causative agents. Okay, so let's switch to healthcare, and I would assert to you that we have to do something similar. even though I'm not an expert on healthcare or biology. The first thing we have to do, and this is where we are really at the beginning of a technological revolution, is never forget that we have to get the biology straight. There's huge advances in understanding that can be made in the biology, and then we need to apply the processes that I spoke to you about, and the resource management. And it's interesting to think about that in a kind of 2-by-2 structure. One is you have the organization view on the left, and you have the patient view. And then in the 2 columns, you have a business and operational aspect, and second, you have a clinical aspect. And what I'll do in my remaining time is just give you a few illustrations of very interesting things that I find very interesting that are happening in the healthcare work that will fill in several examples on this matrix. I'll pick examples from the 2 squares that are in red there. Quality research. Quality is going to be fundamental in healthcare. And then finally, never forget about risk. Okay? So, starting with the biology, new things are becoming possible. Okay? The modeling of protein interactions using supercomputing. And I just want to show you one example here. This is a blue gene simulation which has finally and effectively explained the behavior of rhodopsin. Rhodopsin is the protein in your eye, in your retina, which converts the incoming photons into chemical outcomes that in fact allow you to see. Okay? It has recently been discovered with simulations, the initial simulations, which used to only run for about 40 nanoseconds on the biggest supercomputers in the world, could not really explain how rhodopsin worked in the eye. But because of advances in supercomputing, and in fact you may have read that IBM recently built and delivered the first petaflop supercomputer, 10 to the 15 floating point operations per second, using a machine that is about 1/3 of a petaflop, called Blue Gene, we were able to simulate rhodopsin for about 2,500 nanoseconds, which is about 2.5 microseconds, right? And demonstrate that the reason rhodopsin works is because of the much slower interactions that occur with water within the retina. So because of a aqueous solution property of rhodopsin, we're beginning to get a fairly good understanding of how eyesight works, if you like. So this is just an illustration of the biology, and there are wonderful things that are going on in human biology and in proteomics and genomics, as you know, and information technology is providing some capability to deal with that. But back to our beloved processes, let me tell you a little bit about a text analysis system. Now, I know this is not the only one in the world. There are a number of research projects going on like this, but this is one that we've been working on with Mayo Clinic and also Memorial Sloan Kettering Cancer Center, which does some interesting analysis of both patient records. This is an example of a patient record that has been parsed and analyzed using text analysis software to try to extract what were formerly unstructured medical records and to try to capture that information in order to predict and create machine learning around outcomes. This is a scanning, if you like, or a parsing of a record of somebody who's come in for treatment of AML, leukemia. This is a second example. This is an analysis of a dictated pathological report, okay, or transcribed pathological report, and the analysis of the pathology of someone who I would guess is suffering from colorectal cancer, from what it looks like here. These kinds of models, systems, which can be used for text analysis, can be used to capture massive amounts of information, which can then be fed into query systems, which allow you to run queries, for example, to find all the records on colorectal cancer that had certain characteristics, and then, in fact, be directed to the actual records, so that you can either then write further queries to carry out research. And this is a particular example of a set of records that have certain lymph node characteristics from metastatic lymph node characteristics for colorectal cancer. So this is an example of how medical records, which were formerly relegated to chart review processes in research, very time-consuming chart review processes, can now be captured and automated and used to create very interesting corpora of data. And an example of this data is the Da Vinci system, which we have implemented with Memorial, which now has 1 million patient records captured, and is allowing people to do very, very interesting things. And I'll just mention one thing here. And if anyone knows about this, I'd love to talk to you afterwards and knows how to deal with this opportunity. One of the things that Memorial Sloan Kettering has been very active is in the production of prognostic models for cancer. And there is the potential for using these new prognostic models, which are based on tens of thousands of patients, to actually redesign and really improve the clinical trial process, and to make one-arm trials possible, and to make trials possible that have much better ethical behaviors and much more powerful statistics in the investigation of new treatments within cancer. So this is the example. Once you can get the data, you can begin to build these models. These models are coming out, and they allow much better clinical trial research to occur. So we talked here about process and data. This is an instance of data being very carefully used with machine learning in a project that our Israel Research Lab, has done in services research to actually gather all the data that was available in 3 databases in Europe, the largest corpora of AIDS data in the world, and actually use a regime of machine learning models to try to learn the relationship between genotype and the right cocktail mix for treatment of HIV. The treatments and the best practices or the standards of care that have come about from this are now beginning to be deployed in Europe. Okay, what about optimizing the processes? Okay, I mentioned the use of operational models before to optimize a variety of systems. This is a system that's being deployed now in the Rambam Hospital in Haifa in Israel, which actually allows the optimal deployment of the resources, or if you like, the inventory of healthcare practitioners, and the optimum deployment of the granting of appointments in order to minimize wait times in clinical situations. And this is data, for example, that shows you the average wait time for encounters and the predicted averages, and using prediction methodology, actually transient queuing analysis, is able to, in fact, predict waiting times and schedule patients accordingly so that overall service levels within I believe this is a first appointment in a clinic in the hospital can be minimized. So the management of these resources and the optimal management of these resources has great potential. And finally, I'll end with the 4th step that I asked you to always think about, which is risk, thinking the unthinkable. Project Checkmate is a project that we embarked upon with Scripps Institute, again using supercomputing capability to model the H5N1 virus. Now, the H5N1 virus, it's now known, can actually be traced back to the Spanish flu. It is a mutation, and the complete provenance of the H5N1 can be traced back to samples that are still available of the Spanish flu. So if you can do that on a supercomputer, why can't you try to predict the future mutations of H5N1, whether it be, I don't know, H6N1 or H5N2 or whatever it is? Why would that be important? H5N1 is a very interesting virus. As many of you may know, it's highly fatal. It's about fatal in about 50% of the cases. It's also not very transmissive, fortunately. It has very low transmissivity. Thanks to the analysis of these protein structures and some other work that's gone on, we now know why H5N1 has those characteristics. Because of the sugar structure on the outside of it, it actually lodges deep in the lungs. So H5N1 patients do not cough, typically. Okay? Now, with the analysis that we can now do on the structure of how the mutations have occurred and how they may occur in the future, we have the potential to pre-build the vaccines, which would otherwise take about 6 months to build. We can pre-build the vaccines for what we believe to be not just the most likely mutations, but the most likely mutations that are likely to lodge high in the lungs and thereby be highly transmissive. Okay? This is just an indication. This work is just beginning. This is just an indication of the kind of thing that you can do now that you have proteomic interactions and you can model proteomic interactions. You can get some new and fundamental attacks on disease. My last example is spatiotemporal epidemiological modeling, a wonderful and politically very interesting project that we're also doing in Israel with the Palestinian Authority and the nation of Jordan, where, as you know, bacteria know no borders, so they have no hesitation to cross the Israel-Palestinian Authority border, and it's both appropriate and I think a very good project to be able to actually do the modeling, both in this is a map of the United States there, but do the modeling through Jordan and Israel and Palestine of the transmission of viruses. We now have models that can be used for bacterial infection and can be used to do detection, and those models are being actually open sourced in a package called STEM, which is through the Eclipse Foundation, is an open source model which includes the predictive Ford equations that you see on the right, which can be used if you can measure the state or the number of incidences in an area, say in the United States or any other geography. You can actually predict the Ford motion, and therefore you can predict where you should take remedial action. So I'm going to stop here. I hope I've given you a taste of everything. My last comment is that we believe that we need a new discipline called SSME, and I think many of you have heard this before. We need people to be broad so they can talk to each other. I've learned more biology, more accounting than I ever thought I would in the last couple of years being involved in this work, being a computer scientist by training. And our hope is that, my hope actually is that healthcare and biology will be the sixth revolution, because I think it offers incredible benefits and it offers wonderful outcomes for mankind. And from a narrow perspective, you might have noticed that, well, we've lost the picture here. That must be because my time is out. But my hope is that the guy on the bottom who looks very crouched and having very bad posture there may in fact be able to stand up, and we'll move forward and expand out of this. So with that, thank you everyone.